Okay, so here we go. So we're starting right here, page 20. It says rate of change and slope notes. So the slope of the line is a number that describes the steepness and the direction. So I want to kind of talk about that over here. So steepness. Okay. It is page 20. It's in the middle of the page. Okay. It's in the middle of the page. We're on page 20, right in the middle. So the steepness of the line. So your slope, which we call m, is the number next to the x variable. Just so you know, it's the number next to the x variable in your equation. So the steepness, if it's between 0, so I have 0 is less than m is less than 1. That means it's going to be a fraction, right? It's in between 0 and 1. So it's going to be very mild. Fractions have a mild steepness, where if my slope is greater than 1, it's going to start to get very steep. So the larger the number over 1, the steeper it is. If it's, when we talk about the direction, if it's positive, if that number is positive, our slope goes like this. If that number is negative, our line goes like this. And we're going to say that a million times in the next 3 days, but that's kind of how that works. This is the formula to find slope when you're given 2 points. We're also going to talk about how to find slope from a graph when you count it. Okay. We're also going to talk about how to find slope from a graph when you count it. Sorry. Yeah, what do you got for me? Yes, you can. We're on page 20. You got to pick up your pencil. Right? We're writing stuff on the board. Writing stuff. Okay. All right. So let's go down to those graphs. So those graphs just show you what the slope looks like from a perspective of a coordinate grid. So positive slope, just like I said, as you read it from left to right, you read it from left to right, y is getting bigger. That's what positive slope means. It means that y is getting bigger. Okay? Y is getting bigger. If you have negative slope, again, you're going to read it from left to right. But you notice that y is getting smaller. And I just want to talk about that so you understand what I'm saying. When I say that y is getting bigger, I'm going to shut off that front light. When I say that y is getting bigger, we're going to look at the y values. I want to look specifically at the y values of my graph. Copies of my filled out notes. So when I look at the y values, here, what's the value of y at this point? X is -4, y is 0, correct? Y is 0 right here. What's the value of y here? 5. So y is getting bigger. As I read it from left to right, y is getting bigger. Let's look at negative slope. When I think about negative slope, right now y is 1, 2, 3, 4, 5, 6. Y is at 6. The value of y is 6. But when I go over here, what's the value of my y? 2. Y is getting smaller. Anywhere on those two lines, anywhere that you pick it, if you go from left to right, you're going to see that's how you determine if your slope is positive or negative, if you can't look at the graph and see that it's going down versus up. Okay. Then we have two types of slope for horizontal and vertical lines. So 0 slope means that your graph never rises. So there's no slant. So when we think about slope, slope is rise over run. And if you never rise, if your line never goes up, that's 0 over any number, 5, 7, 10, whatever. What is 0 divided by anything? It's still 0. That is why your slope equals 0. This is horizontal. Okay. This line is a vertical line. So this has undefined slope. And let's talk about why that is. If I were to think about these 2 points, I started at 0 and I went up 5. So my rise is 5 units. But how much do I tilt to the right? What's the difference from the right between these 2 points? What's the x coordinate? Does it slant at all? No, it's going to be 4 minus 4 or 5 minus 5, which means it doesn't have any slant. So it's 0. What happens when you divide by 0? Yeah, you get no solution. If you divide by 0 in a calculator, you get an error message. It says domain error, divide by 0, something like that. And that's because it's undefined. You cannot divide by 0. That's why if we have undefined slope, it just means that your line is vertical. That's all that means. Okay. Undefined slope means that your line is vertical. Then we're going to talk about how to find slope from a graph. So go to page 21, and I want to talk to you about finding slope from a graph. So when we count slope on a graph, we're always talking about the rise, which is the y, the change in the up, down, the vertical, over the run, which is the change in the x, the horizontal. So if I started at this point and went to this point, that's what this is showing you. My rise is 1 unit and my run is 3 units. So that means that my slope is rise 1 over 3. Then it says, hey, well, let's look at this next set of ordered pairs. I'm going to go from this point to this point. So my rise is 3 and my run is 9. Well, 3 over 9 reduces to what? 1/3. So it doesn't matter what 2 points you pick on the line. It doesn't matter what 2 ordered pairs you select. You're always, a line has 1 slope. Does that make sense? It's not going to be different. The slope isn't going to be different on different points. Okay. So the slope of this line does not change if you pick different coordinates. It's always going to be the same. And then we're going to use that formula. We're going to take 2 ordered pairs in our next example, and we're going to use that formula. So m, which is my slope, equals y2 minus y1 over x2 minus x1. So the first thing that I do is I write down my ordered pairs. So I have -9, -3, and +6, 2, and I label these. What is an ordered pair made up of? 2 what? Coordinates. What are they? What are the coordinates from? Yeah, x and y. So this is my first x and y coordinate. And because it's my first one, I call it x1 and y1. This is my second ordered pair, right? So this is my second x coordinate and second y coordinate. So I call it x2 and y2. And then I just know that I'm going to put something in for my y1 and my y2 divided by something for my x2 and my x1. Oops, I didn't want to write it. I just put little parentheses there because I know that I'm just going to insert some values in there, right? So what is the value of y2? So That's what goes first. Well, I go over to my two ordered pairs and I have what labeled as y2? Yeah, the coordinate 2 is going to go here. 2 minus, what is the value of y1? So minus -3 over, what is x2? Say it. 6 minus, what is -9? Good job. So what do we know about minus and negative? What happens when we have minus and negative? Yeah, we turn that into a great big plus sign. So I really have 2 plus 3 in the numerator, which is 5, and 6 plus 9 in the denominator, which is 15. Can I reduce that? Yeah, I can. What does that become? It becomes 1/3. Because those are the ordered pairs from that graph right next to us. Okay, so your slope is 1/3. Sometimes you can calculate the slope from a table. And probably I think this is the easiest way to calculate slope. I think you guys do the best with this method. So calculating slope from a table. So when we talk about slope, we're always talking about the change in the rise, which is the y-axis, over the change in the run, which is the x. So change in y over change in x. So I just want you to tell me, to go from 5 to 7, what do I do to my y coordinate? To go from 5 to 7, what do I do to my y coordinate? I add 2. To go from 7 to 9, put your head up. To go from 7 to 9, what do I do? Add 2. To go from 9 to 11, what do I do? Add 2. So I just write plus 2, plus 2, plus 2. So my change in y is 2. It's constant. It's the same the whole time. Let's talk about my change in x. It goes up by 1 every single time. 0 to 1, I added a 1. 1 to 2, I added a 1. To go from 2 to 3, I added a 1. So my change in my x is 1, which means my slope is 2 over 1, which reduces to 2. Okay. Does that make sense? I think tables are the easiest. I want you guys to look at table B. Tell me what your change in y is, and tell me what your change in x is. Change in y, change in x. Sorry. So example B. Let's go over there. Let's see. So I went So I think I went down 3 on the y-axis and plus 1 on the x, right? So my change in y is -3 over my change in x, which is +1. What does that reduce to? So my slope is just -3. Is it okay if I write it as -3 over 1? Yeah, because that helps you count it, right? That helps you count it if you have to count it on a graph. Yeah, for sure. Okay. What about example C? Someone tell me, what am I doing to the y-axis? Am I adding 2 every single time? Okay. Sometimes that might not always be consistent. You have to watch for that. What about on the left side? I'm also adding 2 every single time. So say that again. It's 1. Because when I take a +2 over a +2, that reduces to 1. Thoughts? Is this making sense? Are you understanding how we're looking at the change in the y? No, it doesn't? You're joking? Okay. Going across? Yeah, we're talking about the vertical change. Up and down, up and down. Okay. And your X, they're listed up and down, right? So since they're listed up and down, that's the way I want you to think about it. The biggest mistake here is that kids do the X first instead of the Y. Y always comes first. Why? Because I said so. I don't know. That's a little joke that we made last year. Okay. Let's look at this one. So we're going to do this two ways. We're going to graph it and count from the graph, and then we'll check it using the slope formula to make sure you guys understand it. So I'm going to write my points a little bit closer to my graph so we can see the ordered pairs and the graph. So my first point is the ordered pair 1, 1. So when X is 1, Y is 1. My second point is the ordered pair -2, +6. -1, 2, +1, 2, 3, 4, 5, 6. And because we're talking about a line, I want to draw a line. So how do we read a graph? From left to right. I used to say just like you read a book, and then they made those books that go from the backwards to the front. And yeah, so that doesn't always work. So if I want to go from this point to this point, the first thing I have to talk about is my rise. That's this. Am I going up or down? I'm going down. So I'm going to draw an arrow like this. And then my run is going to go this way. So let's count. How much do I go down? Well, I go down 1, 2, 3, 4, 5 units. And because it's going down, it's going to be negative. And then we always run to the right. We always run to the right. And I run 1, 2, 3 units. So by counting this on the graph, it says that my slope is -5/3. But you know what? Sometimes I just don't count very well on a grid, and I want to make sure that I did it right. So I'm going to label these points X1 and Y1, X2 and Y2. Plus, I want to give you the extra practice of putting it into the slope formula. Y2 minus Y1 over X2 minus X1. So the first thing that I do is I just set up parenthesis minus parenthesis over parenthesis minus parenthesis. That just helps me remember what I'm doing, and I just plug them in. It's just a quick way to plug stuff in. So Y2, what is the value of Y2? It's 6. Yeah, Y2 we labeled as 6. And what is the value of Y1? A 1. Okay. Over X2 minus X1. So what is the value of X2? -2. Minus, what's the value of X1? Okay. So the numerator is 6 minus 1. What is 6 minus 1? 5. And the denominator is -2 and -1. Are the signs the same? So that means I add those together and keep the sign. -2 and -1. Well, 2 plus 1 is 3, and it's going to be negative. So my slope is 5/-3. Is that the same thing that I got on my graph? Yeah, it is. Even though the negative on one is in the numerator and the other one is in the denominator. A positive divided by a negative or a negative divided by a positive is still negative. So they're the same. Okay. Does that make sense? Okay. Let's do the next one. The next one, we're going to do the same thing. We're going to graph it first, count, and then we'll check it with our formula. So I have the points 0, -5. Oh, no, that's not negative, is it? 0, +5. Sorry about that. 0, +5, and 10, 0. Okay. So my first point, 0, +5, when X is 0, Y is 1, 2, 3, 4, 5. And then my next one is 10, 0. X is 10, Y is 0. So that's this line like this. Okay. So tell me, is this, do you think, going to have positive slope or negative slope, and why? Why, Gerardo? Yeah, as x gets bigger, what's happening to my y values? They're getting smaller. Y was 5, and now it's 0, right? So I know it's going to have negative slope, meaning I'm going to go down first. How much do I go down, and how much do I run to the right? I go down 5, and how much do I go to the right? 10. So my slope is negative 5 over 10, which is the same thing as negative 1/2. Okay, let's put it into our formula and see what we get. So again, I'm going to label this as my first point, x1, y1, my second point, x2, y2. So the formula, y2 minus y1 over x2 minus x1. And then I just set it up as parenthesis minus parenthesis over parenthesis minus parenthesis. It's just a good habit to get into, so that way you don't get confused on minusing and negative, because that's where I see mistakes. So what is the value of y2, Kian? 0. What is the value of y1, Sophia? It's 5. Yep. What is the value of x2, Jerry? Jerry, I've got it labeled up there, x2. 10. And what is the value of x1, Nathan? Look right here, Nathan. I've got it labeled. Good job. All right. 0 minus 5 equals what? Equals negative 5. 10 minus 0 is what? Can I reduce that to what? Yeah. I take a half point off if you don't simplify your fraction. I'm going to move on to the next one. So slope you try. Here's what we're going to do. Who wants to go up and do letter A on the board? Kian, you do A on the board. Right, nice and big so everybody can see it. Who's going to come up and do B on the board? Okay, come on up, do B. Who's going to do C? Anyone? Anyone? Kian, you're right here. A. Slide over. You got it, muscles? Let me see it. Who's going to do the next one? Carter, come and do C. Right, nice and big so everybody can see. You are great. Do it up. Pick 2 of those to copy down from them on the board. I'm going to freeze the screen and do them as well, so they're in our video notes. -7. The last order pair is -1, -7. Good call on that. Perfect. Thank you, sir. So are the signs the same or are they different? What's the formula? Isn't it y2 minus y1 over x2 minus x1? Yeah, you got them backwards. You got your x's. You need to put your y's on the top, x's on the bottom. What happens when you have minus and negative? Yeah, you don't, not you, you're fine. Look right here. So, okay, so hang on a second. So it's y2 minus y1. So you have y1 minus y2, and it's going to make it, you have to do this. Well, because in the bottom you had it x2 minus x1. You have to do it the same way. So in the top, negative 7 minus 4. In the bottom, negative 1 minus negative 2. Are the signs the same or are they different? So you add them together and keep. The signs are the same. You add them together and keep the sign. See if you can reduce it.
That's going to be like a half number.
It is. It's exactly that. It's going to be a half. No. Flip flop. Get rid of that. What? Divide both the numerator and the denominator by 3. Divide by 3. So right, divide by 3, divide by 3. So this was minus. There's no negative here, right? They are. Are the signs the same? Negative 7, negative 4. So you add them together. 7 and 4 is 6 divided by 3 is 2. 11. The sign. This is just. So they were two negatives, right? Make it positive. So the signs are different. What is 2 take away 1? The signs are different. Yeah, perfect. Write it nice and big. So number A, I know it's not a number. Letter A, Kian got a slope of 1. That is correct. Letter B, Eleni got a slope of negative 1/2. That is correct. And letter C, Carter got a slope of negative 11, and that is also correct. Eleni, Kian, and Carter. I know it's hard to get up there and like volunteer your. It's hard to be in front of everybody. So when you guys do that, I give you +1 because I just think it's important to do that. So this is in our notes. I'm gonna keep going. Okay. So in our next example, we're using the table. In the next example, we're using the table. Who feels like they can do a table? You already went. So Gerardo, go race A, and you have to draw out the table, okay? You have to draw out the table. Who wants to do B? Someone other than Ken. He's already gone. Who wants to get an extra credit point? No, Rylan? No? Go on up there and do B. I'll do C. B and C are different. It's asking you if it's linear. B and C are tough. So make sure you draw out your table. I froze those slopes up at the top, so if you guys didn't get those written down, you can. So I have a question for you, Gerardo. Is the slope the same for each ordered pair? Like as you go down, is it consistent? Are they all -2 over +3? Perfect. So write linear next to that. Write linear, if you would. Thank you. So what's happening over there, bud? It's not the same. The rate of change is not the same. So that means it's not linear. It is not the same. So that means it's not linear. So if your rate of change, if that slope is not consistent, then you are not going to get a graph. You're not going to get a graph that has a nice straight line. So I'm going to do example C with you. So I'm going to move up so we can all see it. So example C, notice that on my y-axis, I go up by 2, and then I go up by 4, and then I go up by 8. On my x-axis, I'm going up by 1 every single time. So if you think of this as the change in y, am I still frozen? I'm so sorry. If I think of this, thank you, sir. If I think of this as the change in y over the change in x, I get the fraction 2 over 1. If I think of this next one as the change in y over the change in x, I get the fraction 4 over 1. And if I think of this last one as the change in y over the change in x, I get 8 over 1. Those are not the same. Those are not the same. This is not linear. It's not going to make a nice straight line. This one went down by 3, down by 2, and then down by 3 again. This one is also, if this is not consistent, if these numbers are not the same, and these numbers are the same, +1, +1, +1, you're going to have something that is not linear. Okay.
So, like, if we were to be given that and we're told to graph it, what would that look like?
So if you were to graph that, it would look like, that's a great question. If you were to graph something like that, it would be segments. It would look like this, and then maybe it would get steeper like this. It would be segmented chunks.
That would be like those word problems where it's like somebody travels.
Exactly. Like from this time to this time, they traveled 2 miles per hour, and then they increased to 4 miles per hour, and then to 8. So, yes, exactly right. Okay. We're going to stop right there. We're going to stop right there. We're going to pick up with this tomorrow. So, we're going to stop here for our notes. And your homework is not a paper assignment. Your homework is Delta Math. Your homework is Delta Math. I'm going to go to our module.